Coffee is life. It's also a homogeneous mixture. And that's what this video is all about, mixtures and all the terminology that goes with it, homogeneous and heterogeneous mixtures. I hope I pronounced that right. At the very end of the video, I am going to post an exam summary for you guys to take a screenshot of if you need it. Let's start. What is a mixture? It's a mixture of stuff, but you can't write that in your exam. So here's an exam definition. Mixtures. A collection of more than one pure substance in no fixed proportion. In the definition of a mixture and of a pure substance, which I did mention in the previous video, link in the description below if you want to go check that out, there's a clear difference between pure substances and mixtures. And that is that a mixture occurs in no fixed proportion or ratio, but a pure substance, however, must occur in a fixed proportion or ratio. The word proportion and ratio means the same thing. Sorry, I'm using them interchangeably in this video. Now, what the heck is that actually? What is a fixed proportion or fixed ratio? What does that mean? For example, water, which is a pure substance, has a ratio of 2 hydrogens to 1 oxygen, H2O. But now, if this ratio of 2 to 1 changes, then it's no longer water. Say suddenly it changes from 1 hydrogen to 1 oxygen, a ratio of 1 to 1. That means it's no longer water, it's now a hydroxide ion, and its chemical nature has changed. Therefore, the entire substance has changed. Where in a mixture, however, it's completely different. For example, let's take coffee. If you add like 2 spoons of sugar, 2 spoons of coffee, and a cup of hot water, at the end of the day, it's still going to be coffee. Even if you add maybe 6 or 7 spoons of sugar instead of 2, and you completely change the ratio, you can change the proportions as much as you like. It's going to end up coffee. It'll be a sweet cup of coffee, but okay. Some people prefer it that way. Okay, why is this true? Why is it that pure substances must occur in a fixed proportion or ratio, but mixtures can do whatever they feel like? Okay, in order to answer this question, we're going to have to address the properties of mixtures. And that is the following. Substances in a mixture do not chemically bond together. Each substance in a mixture, regardless of the type of mixture, will maintain its own chemical properties. The components of a mixture keep their separate identities and properties. Coffee, for example, sugar is sweet, coffee is bitter. That'll never change. They will keep those properties, those chemical properties. Whereas a pure substance, if you change the proportion of the components of a pure substance, the substance will completely change and its chemical properties will change as well, and its identity. For example, with the water example, water has a ratio of H2 to 1 oxygen. And then hydroxide, when you transform water into hydroxide, that's 1 hydrogen to 1 oxygen. And then hydroxide is an ion, so it's chemically charged. It's a lot more reactive than water. And those chemical properties have now changed. For those of you that haven't learned this yet, a compound is an ion if it is electrically charged. So all of those little compounds that you see with the plus and minus sign, and even the individual elements with the plus and minus sign, those are all ions. There are 2 types of mixtures. The first being a homogeneous mixture. Exam definition. Homogeneous mixture. A mixture which has the same uniform appearance, composition, and phase throughout. The words uniform appearance in that definition of a homogeneous mixture simply means that the mixture looks the same throughout. For example, this. I mixed vinegar and water together, and that's what's in this glass. Now, you can't see that it's vinegar and water. It's a glass of some clear, transparent liquid. But this is a homogeneous mixture. It's uniform throughout, it's the same phase, it's liquid all the way through. And yeah, vinegar and water is an example of a homogeneous mixture. If asked in an exam to give an example of a homogeneous mixture, you can say miscible liquids such as food coloring and water make a homogeneous mixture. Now, I feel I need to clarify the word miscible for a minute here. Nobody seems to know what it means, but we all write it down in our exams though. Miscible liquids. Liquids that mix in all proportions. And you know, what does that mean? For example, orange food coloring and water. Doesn't matter how much orange food coloring you add to the water, it'll always just look like orange water. It might look more orange or less orange depending on the amount of orange food coloring you add, but no matter how much you add, you will never end up seeing like a situation with water and oil. You will never ever see that they do not mix together. They will always mix together no matter how much you add. Okay, moving on. The second kind of mixture is called a heterogeneous mixture. Exam definition: heterogeneous mixture. A mixture that consists of visibly different substances or phases. For example, heterogeneous mixtures are immiscible liquids such as oil and water. Now, what does the word immiscible mean? Immiscible: liquids that do not dissolve in one another to a significant extent. Now, the classic examples are old, so I want to use something a little different. I want to use molten silver and lead, just to mix things up a bit. No. What do you mean no? I mean no, the YouTube budget is finished. No. Stick with the classics. Fine, I'll stick to the bloody classics. This is high school after all. Alright, so sticking to the classics, oil and water. Oil does not dissolve in water at all. They are clearly distinguishable from each other, as you can see here. Doesn't matter how much I mix it, doesn't matter. It will constantly just not mix. And oil will stay above water, at least migrate to the top of it, and just form a layer of oil on the top of water. Okay. Now, heterogeneous mixtures actually come with a little bit of extra jargon, and that would be a suspension and an emulsion. Let me explain. A suspension is a heterogeneous mixture of solid particles mixed with liquid. For example, sand and water, or at least that's what this textbook says, and proven existence of beaches. I'm so sorry, I didn't mean that, it was just for the audience, okay? I'm so sorry. An emulsion is a heterogeneous mixture with a stable distribution of a liquid in another liquid, for example, oil and water. Now, the reason we use the word stable distribution in that definition is because substances that are stable do not spontaneously react with one another. So oil and water are not going to react with each other and form a compound, or no chemical reaction will take place. And of course, you can clearly distinguish water from oil, therefore it is a heterogeneous mixture, and liquid in a liquid that you can clearly distinguish each liquid from the other, emulsion. Since in a mixture no chemical reaction occurs, each substance keeps its own identity and properties. Therefore, each mixture, every single mixture, can be separated by physical means. What are some of the methods in which mixtures can be separated? Real quick, if you have any questions, please drop them down in the comment section below. If this video has been helpful so far, click that like button. And I will actually tell you in the next video what some separation methods are for mixtures. In the meantime, here is your exam summary. It is 2 slides long, just telling you. If you want to stay tuned for more, please do subscribe, and all the best. Hope to see you next time. I got lipstick all over my cup.